fixed point iteration converts a root finding problem into a repeated function evaluation. No derivative required, no bracket needed. Rearrange f of x equals 0 into the form x equals g of x, then iterate. The iteration converges whenever the mapping is a contraction near the root. To solve f of x equals 0, rewrite it as x equals g of x, so the root x star is a fixed point of g. Then generate a sequence by plugging each result back in. Convergence is guaranteed when the absolute slope of g at the fixed point is less than 1. The smaller the slope, the faster the convergence. If the slope exceeds 1, the mapping pushes iterates away from the root. You must rearrange f into a different form of g. The convergence rate is linear. Each error is multiplied by the slope magnitude at the fixed point. The cobweb makes the iteration visible. From x0 equals 1, rise vertically to the curve g of x that gives 0.4, which is x1. Now move horizontally back to the y equals x line. Rise again to g of 0.4, which is 0.213, that is x2. Each V-shape is smaller than the last. The staircase spirals down toward x star at 0.2016, the fixed point where the two curves cross. Solve x cubed minus 5x plus 1 equals 0 by rearranging to x equals x cubed plus 1 divided by 5. Start at x1 equals 1. The slope of g at the root is only 0.02, so each step cuts the error to about 2% of the previous. Very fast linear convergence. 4 steps bring us to the root at x star approximately 0.2016 with residual below 10 to the minus 3. Define g underscore fp for the mapping and run a duplicate chain of 8 steps. The second duplicate tracks the original equation residual for comparison with the table. The Colebrook equation can be rearranged directly into fixed point form. ff equals 1 over negative 2 times log base 10 of epsilon over d divided by 3.7 plus 2.51 over reroot ff all squared. Starting at ff1 equals 0.02, the sequence converges in just 3 steps. 3 steps is all it takes. The Colebrook FPI rearrangement is the standard trick used in piping codes around the world. The function g underscore cb underscore fpi implements the fixed point rearrangement. An intermediate variable, arg, breaks the long formula into 2 readable lines. Fixed point iteration. Week 1.